Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 28th. Looking at the South Pacific Ocean significant wave height charts, we see a gale, 37-foot seas, passing south of New Zealand, aimed basically to the east, but also in a good position to push swell up into Tahiti, Hawaii, and the U.S. West Coast. This is just a primer system. There is more behind it. Otherwise, there's not a whole lot going on. This area of the Pacific Ocean is of main focus. And also the West Pacific on the equator. We'll get more into that in the long-term forecast. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of storms. And when those storms do form, help direct their track. Currently, we have a trough that is a little push to the north building here south of New Zealand. This is what is helping create clockwise circulation, which is low pressure down at the ocean surface, and supporting the gale that we saw that was producing 37-foot seas in this area. But also notice a ridge building into Antarctica, pretty much covering the entire rest of the South Pacific Ocean. Let's put this into motion. As we move forward, we see the trough that's supporting the gale currently is pretty much going to fade out. This ridge here just cuts it off, but also notice another trough appears to be building directly behind on Monday, and there we go. By Monday night, it's decent, not a lot of wind here supporting it. Only 90 knot winds or so. We'll see what happens. That trough continues and builds into the southwest Pacific into, Tuesday night or so. And then it too sort of falls apart. Notice these southward falling winds here. And yet another trough builds behind that on Wednesday. Kind of pinched off, but it sort of makes its way into the Southwest Pacific, and then it too fades. And then it almost looks like another trough behind that on Friday night, following much the same route, though not clearly as defined. And then we roll this out, and yet another trough starts building 180 hours out. This one coming way up, pushing way to the north here. This would be yet another system we would want to watch. Let's take a look down at the surface and see what the impact of these upper level winds is supposed to have. So here we are, 18Z run of the model this Sunday. Currently, the gale south of New Zealand with 40 knot winds pushing better to the northeast than the wave model would suggest, meaning that maybe a little bit more energy is going to push up into this region than would be apparent just by looking at the wave model itself. Anyway, we'll put this into motion. You see this gale pretty much falls apart, but look at this back here under Tasmania Monday morning. 55 knot winds building, small area but solid, pushing well to the east. The point being here that there's a lot of talk about Fiji. Certainly they will get swell because there is supposed to be fetch aimed reasonably well there, but when we get into the wave model chart, you'll see the great circle paths for Tahiti, U.S. West Coast. They all pretty much are almost flat west to east here in this region, which means this is actually pushing perfectly up into the Northern California and the Southern California swell window. And here we go. 18Z Monday, now we're up to almost 60 knot winds, and then that fades out by Monday night. Still 50, 55 knot winds, again aimed pretty much the same, continuing and lifting to the northeast. Look at this, almost south fetch there. This is Tuesday morning, and then here you go, good southwest fetch, but down to 40 knots by Tuesday night. And then this thing sort of peters out. Though there's still fetch there. Notice another system right behind it. 40 knot winds. Now this is aimed much better towards Fiji. Straight, right up in through the Tasman Sea. Swell would result for that. Notice it's almost pushing to the north. We'll go back and look at this. It's the direction that the fetch moves and the wind itself. And it has a pretty good little push there to the northeast. So that's probably better for Fiji. And then another system behind that on Friday. Oh, even 45 knot winds under Tasmania. That's more of a Fiji system as well. Also notice a little bits of spurious energy even way to the north. Probably not much in terms of swell production. And then we go 180 hours out, and yet more activity is going on in this area. The point being, we suspect that the MJO, which is strongly in the active phase, right in this area, typically, if you're going to have impacts north or south, it would be north or south of where the peak of the MJO is. So it would not be surprising to see activity in this area right now, and we'll get into that more in a minute. Let's go take a look what the impact of these winds are going to have on the ocean surface. So here we go, significant wave heights for the South Pacific Ocean, and we're actually going back in time to Friday, the 26th. Notice this small system, but rather potent, 46-foot seas under southwest Australia. Let's put it in motion. This system fades a little bit, but still we're looking at 45-foot seas or so on Saturday, coming under Tasmania relative to Fiji here. Though this energy, notice the arrows here are mainly pointed to the east, sideband energy still will radiate up into the Fiji Swell corridor. And then here we go. We're currently, here's where we are right now. Now I'm going to actually put this back just a little bit. And let's do, let's say Northern California, Great Circle track, and this track right here. And notice, even back here, we'll actually see how, so here's the shadow. We're going back to Saturday. Here's the shadow, here's New Zealand. So anything that's in here is not going to make it. A little bit of energy here, maybe up the path, but there's a lot of islands here. Probably nothing for California in here. And whether it's Northern California or Southern California, it's all about the same. But come, Saturday night, you see, let's just be, there we go. So then that was 32, 4, maybe 36-foot seas up about the 219-degree track into Northern California, and basically about the same for Southern California. What's that, 218, 219, sure enough. Then relative to Hawaii, though, certainly not for Hawaii, because see the boot here, it kind of just blocks everything relative to Hawaii. Anyway, put this more into motion, and then we're into Sunday, current time right now, still energy, and notice the Great Circle tracks here and the arrow there. If you're within 30 degrees, you're good for having maximum energy pushing. So there's energy, certainly, and unshadowed. The Tahitian swell shadow relative to Northern California is about 211, 212. So we're clear there for Northern California. Southern California, it's steeper than that, and it's already shadowed by this point in time relative to Southern California. Relative to Hawaii, we'll actually put this back one frame. That's when this system moves into, there's the 201-degree track. That's the cutoff for Hawaii. So it's just moving in there. So the point being, there'll be swell, nothing huge, but sort of a primer. Really, it's a primer storm to stir up the ocean in this area. Now, we'll roll this out because we know there's another system coming behind, and here it is. This is Monday, 12Z, just a little area, 40-foot seas, but just for laughs, we'll look at this, and you see it is shadowed still relative to Northern California and certainly everywhere else. But then we're into Monday night, 49-foot seas, not over a huge area, but look at this. Here's the what is that, about the 222-degree track, and it's south of there. It's in line for Northern California, in line for Southern California. Probably not for Hawaii, though, no. Definitely shadowed for Hawaii. Now, see, 48-foot seas, you'll get probably 25-second forerunners from this system if it does as forecast. Anyway, so then we're into, let's say Tuesday, same deal, lifting a little bit north, right in here in the, what is that, like 218 to 222-degree track, and pushing almost right up the Great Circle paths to Northern California. And same deal for Southern California. And for Hawaii, now it is just moving into the swell window. See, there's the cutoff right there. There's the that point in New Zealand. Anyway, we'll roll it out a little bit more. And then it starts fading after that. Still in the swell window, but then moving. It's beginning, and you can't really tell it here, but here's the, relative to Northern California, shadows for Tahiti. It's starting to move into the shadow for Tahiti to Northern California, and well shadowed by Southern California for that point in time. And then it fades out right after that. Anyway, next system comes underneath, doesn't do a whole lot. Relative to sea production, and now we're 136 hours out. Now this system, we don't have Great Circle charts on this one for Fiji, but there's, you can see just right here, there's good energy pushing almost directly right up there towards Fiji. So more swell for Fiji, and then we'll roll this out. We're out at 180 hours out. We saw low pressure in this area, trough developing. You can see it way off back here, so it's not even showing up yet on the surface level charts at all. But it looks like a good run of swell is possible for Hawaii, certainly Tahiti, certainly Fiji, U.S. West Coast, and all down into here. Just for laughs, we'll just do Costa Rica. Now, let's look at this. Costa Rica, relatively straight east or straight west winds, a straight east swell track. That's good for Costa Rica. And we'll do Peru for that matter. Now, notice here, the winds almost have to be pushing southeast to work it up their way into Peru. So the thought is this is mainly going to be a swell starting somewhere around up in here and these points northward and from a very southwest direction. So that looks pretty good. And just a real quick look here, swell-wise, there's nothing going on for the North Pacific Ocean. We're just doing a quick examination of the jet stream here just to see how it's doing. Looks a little bit fragmented as of current, not quite as good as last week. But then it starts getting better organized again on Thursday. And we're talking in July. Look at this. Knot split, solid winds, 130 knots, falling into a trough on the dateline per the models, and then it looks like it starts splitting here over in the East Pacific. But we're not even into July yet. It looks pretty good. So the question is this a hangover from last winter, or is this the start of something for this winter? We say the dividing line is July 15th. But as of right now, things are looking pretty good. We'll see how this plays out. We're looking for early signs of El Nino's impact on the upper atmosphere in the North Pacific to give us some clues of what's coming for the fall and winter. So far, looks pretty good. Indeterminate at this point in time. Give it another 2 weeks. Let's go talk about the long-term projections. There's major activity going on. And when we say major, we mean major. Take a look at this. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti here, Darwin here. Negative numbers, daily numbers, represent at least the active phase of the MJO. If prolonged enough, then El Nino. We are on a bender right now. Minus 44, minus 48, minus 40. These are deep numbers. If this keeps up for another week, that will definitely be a good sign. We need it more in a week. We need it a month or two. But anyway, right now, the 30-day running average is neutral, suggesting neither El Nino nor La Nina nor the active phase of the MJO, but quickly deepening due to these numbers. But the 90-day running average is down at -8. So this is about where we've been for, it started last October, and we've had variations on it, but we've been in the -5 to -8 range for a good long time now. We want to see this starting to really drop into about the -15 range. That would be a clear-cut sign of El Nino. But right now, we are on the right direction. All this courtesy of the active phase of the MJO pushing through the West Pacific and interacting with an El Nino base state across the equatorial Pacific. And here's a quick way to view the 30-day running average of the Southern Oscillation Index over time. 2013 in La Nina range, 2014 trying to get going, but here we are, 2015, like I said, down around -8 where we've been hovering. We went through sort of a big spurt of the inactive phase, and here we are now going on an equally deep spurt in the other direction. We want to see this fall back down into the 30-day running average, at least down to -15 and preferably below that, to suggest that a major El Nino is starting to take shape. Right now, this pattern is still suggesting that El Nino's not quite coupled with the atmosphere, but it's trying. Next up, surface wind deviations from normal for this time of year. Australia, New Guinea, Philippines, West Pacific. Normally there is trades in this area. Normally the winds are blowing from east to west. This is showing anomalies, very strong anomalies. The Kelvin wave generation area starts here at 130, goes to 170. Draw a box like this, and you can see that we have strong westerly anomalies per this. This is up at about 4,500 feet, but is a good representation of what's going on down at the surface. Westerly anomalies in the entire Kelvin wave generation area. The thought is we are already underway for another Kelvin wave being generated. And for those that don't know, Kelvin wave is a pocket of warm water that when you have westerly anomalies develops in this area, falls to depth, travels across the Pacific Ocean on the equator, gurgles up off of Ecuador, and then starts getting caught by trades over there, pushed back to the west, and that is the hallmark of El Nino, warm water building up in the East Pacific. Anyway, there's one massive Kelvin wave already situated just off the Galapagos. It's almost a semi-permanent reservoir of warm water. This will create yet another Kelvin wave. Probably not a distinct Kelvin wave. What it's going to do is pump more warm water into that reservoir, and probably a lot of it. And then looking to the east, here's Hawaii. The date line's over here. We see just neutral anomalies, and it's right on the equator that we're worried about. You know, we're not so much looking for anything right here. Those westerly anomalies in the far west Pacific in the Kelvin wave generation area are a clear sign of a major MJO, Madden-Julian oscillation, active phase, working its way across the West Pacific and interacting with El Nino. And here we go, a week out, same region, yet more strong westerly anomalies. The reality is these are out and out westerly winds going on down at the surface, and we'll get into that in a minute. The other point to notice here, low pressure, either side of the equator. When you get a very strong westerly wind burst, basically the whole atmosphere starts going this way, and you get these eddies on either side. It goes counterclockwise in the northern hemisphere, counterclockwise in the southern hemisphere. Low pressure, dueling tropical systems on either side of the equator. Not unusual, classic sign of a major westerly wind burst and the precursor, perhaps, to a significant El Nino. And a week out, you see the westerly anomalies starting to make more progress to the east. This is as the MJO starts working its way to the east. Not particularly strong, and we don't care so much. It's this area between 170 west and then back off to about 130 east. That is the main area where if you have westerly anomalies, that's what gets the Kelvin waves produced, and that is what we want to see if you want to see El Nino. Here's another way to look at it. This is from the TAO buoy array. Actual wind directions, wind speeds, and water temperatures. Of course, trades in the East Pacific. This is the West Pacific over here. Now notice, these are not anomalies. These are actual wind speeds and blowing quite brisk from west to east, almost to the date line here. Very good news. And of course, the anomalies also strong in the entire Kelvin wave generation area, making it over the date line to a point almost south of Hawaii. Actually, Hawaii is over about here, but still early MJO activity in the far west Pacific getting great traction on the ocean surface. And we'll bore you with yet one more view of it. Here, the Kelvin wave generation area, our rendition of it, is clearly defined. Some would say maybe up to 5 or 6 north, but we're going to be conservative, say 3 north either side of the equator. Now, here you see, these are not anomalies, actual westerly winds per the 00-hour hindcast in the, 20 knot range. And notice low pressure here, trying to develop. This is current. So what we're going to do, take a look and watch how this plays out here. We're talking 22 to 24 and down here into the 28 to almost 30 knot westerly winds right here in the core of the Kelvin wave generation area. Most impressive. We continue to play this out and it still looks solid. Now notice up in here you're getting more westerly anomalies in the 22 plus knot range. Now look at this. We're into 18Z Wednesday. You have 22 plus knot winds and in spots 26 to maybe 28 knot winds out of the west. Low pressure again, both sides of the equator. Look at that. It just, I mean, if you go with the more liberal, up to 5 north and 5 south, it only gets better and better. Look at this. I mean, this is, again, a forecast, 100 hours out, 30 knot westerly winds in the Kelvin, not anomalies, actual 30 knot west winds. That's enough for wind swell. That's enough for probably 11 or 12 second wind swell to be pushing straight to the east. Very impressive is if this plays out, and it just goes on through almost the most part of the week into about Sunday, and then it finally relents and, down to just what we would this sort of a situation would be, oh, that's a great westerly wind burst with 15 knot winds. And by this time, it's like, oh, that's nothing compared to what was. Anyway, so you get the picture. A lot going on, very strong. This is a significant weather event. So we'll do this here. This is the whole planet. Mainly we're looking between here and here. We're putting things in historical context. The oranges and reds, westerly anomalies, easterly anomalies. So we went through in the middle of June about a 8-10 day run of not easterly anomalies, because it was neutral anomalies at the surface, but up above at 4,500 feet, it was easterly anomalies. But here's the point. Check this out. This is where we are moving towards for the next week. This is the strongest westerly wind burst, supposedly, of the entire year so far, and I think it's even stronger than the one that happened last year. This is the third such one. Now, this is bigger than any, but the third major westerly wind burst so far this year. This should transport a lot of warm water to the east. We would expect another major Kelvin wave to result from this, especially if there's more westerly anomalies off the end of the chart here, which we fully expect there will be. Next up, looking at the models. This is the statistical model. Blues are the less reflectivity off the ocean surface, more clouds, presumably a proxy for the active phase of the MJO. This model suggests about another 5 days worth, and then the active phase fades out and the inactive phase starts to develop. But the dynamic model is just great. Look at this. Basically, the active phase of the MJO builds for the next 10 days and is still quite solid even 15 days out. The inactive phase stays bottled up in the Indian Ocean. And the reality in a real El Nino sort of situation, this is what happens. You end up with a lot of high pressure in here, drought, not a lot going on, where this perpetual active phase sort of lingers over the equatorial Pacific. So we'll see how this plays out. Dueling models here, two different outcomes. This is the preferred option. And the upper level model, now this goes sort of more with the statistical model. The greens are the areas supportive of precipitation, presumably the active phase of the MJO. By about the middle of July, it suggests the active phase is moving out of the picture to the east. The inactive phase moves in, and it does its cycle across the Pacific through about the 7th of August, and then the active phase reappears again. So the point being, we know we're in heaven right now. We know we're in a really good place. The question is, what's going to happen when the inactive phase, if it does come, what it does. What we have seen in major El Ninos from past experiences, that the MJO, yes, it's still present, but it really fades out, has less and less of an impact, especially the inactive phase, because what you end up with is sort of a base state of El Nino going on, which is just westerly winds. This inactive phase works its way over, and if the base state is stronger than the MJO, it just kind of washes out and disappears. But if you get the active phase, which tends to have westerly anomalies associated with it, and you have a base state of westerly anomalies, the two sort of go hand in hand, and the MJO actually amplifies the base state or the west, so you get this perpetual westerly wind thing going on, which means you have perpetual Kelvin wave generation and warm water transport. Normally that starts, you know, right about this time frame, maybe into July, but it's more like the later phases of El Nino. We've been doing a lot of our past, analyses or analogies based on the 97 El Nino and dug up a bunch of data that's, and the MJO didn't seem to modulate as much in 97 as this year, which suggests that the base state on 97 was stronger than what it currently is now. But that could change, because the 82-83 El Nino never really got going until the July or later time frame. We've already been underway since January. So we'll see how this plays out. And yet one more kind of model, a very strange kind of model. You take the world, basically look at the equator, and you go west to east from the maritime continent, let's call it Indonesia, to the Western Pacific, over Americas to Africa, back to the Indian Ocean, and what you do is you plot where the active phase of the MJO is as it works its way around the planet, and then you plot its strength If it's out here, it's very strong. If it's towards the center, it's almost non-existent. And so these, here we are, 1st of June. It works its way through the Indian Ocean. Here we are, and we're up to current time, the 26th, the 27th. And now what the ECMF model is projecting, that the MJO is just supposed to skyrocket in strength over the next 1, 2, 3, 4, 5 days. And then it stalls in the West Pacific and loses energy, but doesn't leave the West Pacific. And that's from an ensemble version here, so lots of different runs. So then we go over to here, the Ensemble Gfs, basically. It's suggesting much the same thing, maybe not quite as strong, but still basically the MJO goes ballistic over the next 1, 2, 3, 4, 5, 6, or 7 days, next week, and then it holds there, but just fumbles and falls apart. That would be fine with us. That would be great. It just means perpetual westerly anomalies right in the heart of the Kelvin wave generation area. Exactly what we want to see if you want to see a significant El Nino develop. Next up, sea surface temperature anomalies. Differences normal for this time of year. Clearly, El Nino signature. Warm water building off of Ecuador, the Galapagos Islands. The main Nino monitoring region is right here. Yeah, you can have all kinds of warm water here, but it has to migrate out here from about 170 west to 120 west. So build a box here. You can see most of the warm water is still bottled up in this area. Trades have not yet really started carrying it at extreme levels into the Nino area, but you wouldn't expect that until the October, November, December timeframe. But as this area warms, what it does is it shifts the Walker circulation this way. The jet stream picks up on it, and the jet stream starts raging in the Gulf of Alaska. That helps support storm development in the winter, and also pushes the jet into California, which would also presumably create precipitation. So, but you have this sort of dual thing with El Nino. You get giant surf, strong storms, amplified jet stream, but then you can also get piles of weather with it, which makes those giant waves not necessarily accessible or rideable. It could be blown out. Who knows? Right now, we're just trying to get the warm water pocket building looking pretty good at the moment. Now we're going to compare it to the 97 El Nino for this time. Notice, at this point in time, this is when the warm water pool relative to the Ecuador area really started ballooning. See, it's not so much, it's not out here in the Nino 3 dot region, but or Nino 3.4, but here it really, we'll just look at the images, a little bit different. This is solid, but really can't compare to what was happening in the 97 El Nino at this point in time. The point, and what was happening is there was continuous westerly winds blowing in this region in June, and way before then, massive pocket of warm water buildup subsurface gurgling up to the surface, and it started erupting in earnest right at this time. What we have now is warm water, looks pretty good. There is a large reservoir of warm water subsurface here, getting ready to erupt. It's just we're a little bit behind schedule compared to 97, and now we have our major westerly wind bursts at the same time. Here is a more detailed 5-kilometer resolution view. You can see pockets 1, 2, 3, 4, 5, 6 of warm water. We can even probably zoom it in here a little bit more, and here you go. And so there's signs of building warm water. These were actually individual pockets even a week ago and a couple of days ago. Now they're all starting to connect. Building warm water here down along Peru, but not extraordinary. I mean, we'd really want to see this whole area filling up. These are 4 to 5 degree anomalies. We can click on this guy. 4.2 degree anomalies right here in this little area by the Galapagos. Pretty impressive, pretty solid indeed, looking good. But let's take a look subsurface. Here's so here's the West Pacific, East Pacific, depth 300 meters. Warm water, normally it's bottled up all over here. You can clearly see it's ridging its way to the east, but is the anomalies that we're interested in. Currently 5-degree anomalies. Actually, this part of the array, here's the buoy anchors, sensors on it, it's down. We think water temperatures are actually higher, and because this data is missing, it's sort of polluting the overall model of the picture. We think that you're actually in 5 to 6 degree anomalies right in here. Anyway, what we're seeing, there was warmer water out here. It's all working its way east here and gurgling up, starting to gurgle up off the Galapagos. But clearly, the path is wide open. As westerly winds here blow in the West Pacific, it's going to start pushing more water, warm water at depth, and you're going to start seeing this pocket building, or you'll see a building another pocket here that's just going to sort of merge in with this one here. Here's another view of it here. Latest image. This one is suggesting you can hardly see it, but basically 6-degree anomalies right on the edge of starting to erupt on the Galapagos here. And also notice lots of warm water still falling to depth. This isn't even from the current westerly wind burst that's in play in the West Pacific. This is just from middle of the road kind of stuff that's been going on. The point being, this is the subsurface reservoir we were talking about that's going to start erupting. Should warm water temperatures more along the Galapagos, Ecuador, and then trades will start pushing it over into the Nino 3.4 region and start raising water temperatures there, while at the same time we have a major westerly wind burst going on that's going to be pumping more warm water down here. What we're getting is this self-perpetuating kind of cycle. You get warm water upwelling, it starts having effect on the atmosphere. The atmosphere in change turns and starts creating more westerly winds. Trades get suppressed, and more warm water starts pumping in. And you get this self-perpetuating cycle that goes on until it all just basically is done and it's overcome in about the December time frame. And then you start falling into a La Nina pattern. But the atmosphere would be so primed towards El Nino that it would take the better part of a year for the jet stream to actually change direction. It's a slow moving boat. It takes a while to go. So we'd be through probably the better part of a year from now, next summer, before, or even early part of next fall, before anything would change significantly. And finally, the forecast from the CFS version 2 model for the Nino 3.4 region. Temperatures currently projected at, or currently estimated per the model here, at about 1.25 degrees above normal. Let's go see what's really happening. The CDAS Nino 3.4 index here currently highest we've been so far, almost 1.4 degrees above normal here the end of June. This is good. So you see, we've actually had warm water in the Nino 3.4 region. Sort of has gone through cycles, had its ups and downs, but hovering in about the 1.1 degree range for, since April. And that's El Nino range for sure. And then it dropped a little bit here, but now we're on the increase again, and we think that the numbers are going to go much higher than this. Also, let's take a look at the Nino 1.2 region. And here we go. This is right by Ecuador and the Galapagos, that region just right close to where the Kelvin wave and where it would erupt. And we've seen that there's been warm waters there. This is over a larger area. We've seen peak temperatures at about, up to 5 degrees above normal, hovering in about the 4.2 degree range above normal near the Galapagos right now. As soon as the next Kelvin wave, that reservoir of warm water subsurface, starts erupting, we expect to see these numbers going up as well. The point being, the model here says we're at 1.25 degrees, and we just saw we're up above that somewhere. The projection is to continue stair-stepping up. In October, we'll be at, 1.8, and then going to 2 degrees above normal in the Nino 3.4 region in the December-ish, late November time frame. The 97 El Nino, if I recall correctly, was about 2.2 degrees above normal, and the 82-83 El Nino was right about 2 degrees above normal. Per the model, we're headed for a significant El Nino event. Just not a strong one, but an unusually strong one. All the data that we've seen so far seems to make this model seem much more believable than what it was last year. So a lot could change. We got an inactive phase of the MJO coming up in July, we suspect. But Let's see what happens. We suspect it will probably have little to no impact. If anything, it'll just sort of tamp down the westerly anomalies for a week or two, and then it'll be back to the same thing. We want to be roaring by the August time frame if we're going to have a major El Nino play out here. But as of right now, things are looking pretty good. So to wrap it up real quick, small storm passed under New Zealand, swell in the water working towards us. A larger storm with, what was that, 48-foot, 47-foot, 48-foot seas expected in the next 48 hours under New Zealand. Another swell on the way, probably will overrun the first swell. And then, of course, majorly westerly wind burst in effect. El Nino developing very nicely. All said, things are about as positive as they could possibly be. This is exactly where we want to be. So that's it. We'll do this again next week. Same time, same channel. Go get some surf. Enjoy it. It looks like things are going to get fun. Thanks.